and data plane. Every device has a plane. So SDN separate, that means the decouple control plane and the data plane. That means the devices are only has a data plane. That means somebody is controlling from the central place. This is a SDN. Like what? Let me give the one example, easy to understand. Let's say, for example, we have a network like this. Let's say, for example, this is R1 is connected with the R2. Here we have R3, R4, and here we have R5. Let's say here we have a network, for example, 10.1.1. For example, the user is a 5. And here we have a 10.1.5. For example, 55. Okay, we need what? Routing. We configure, for example, let's say we configure the OSPF. OSPF select the best path through the cost. So let's, for example, discuss this path is the best path. That means the router will forward the traffic using the best path. So this is the best path. Every router will take their own decision to calculate the best path. We know that. And every router has what? Control plane, that means the CP, I just write down the shortcut, and the data plane, control plane and the data plane. Every device has. Like what? Every device is taking their own decision. Let's say, for example, this user want to communicate with the 5.55. Okay. Now the packet will hit into the router. Router will check the routing or FIB table, check the next hop. That means select the best path and forward the traffic from here. Now the packet enter, for example, into the router number 2. The router 2 also go through the same process because every router has a control plane. That means they are taking their own decision to selecting the best path like this, whichever the best path. We don't want like that. We want what? Okay, we will take the decision through the centralized. So now the SDN says, I will discard or decouple, for example, control plane from the every device. So we remove the control plane, for example. Okay. Now these devices has only the data plane. Now, where is the control plane? So let's say we bring here the control plane, not in the middle. I just make the design here. So this is a control plane, and we normally call SDN controller. The different name of the different vendors. Okay, so let's talk about the SDN controller. Now what? For example, you as an engineer, you are accessing, managing this controller. That means you are sitting here, whatever you want to deploy the configuration, whatever the policies you want to deploy, everything you configure where you configure here in this your workstation. Through where? Through the graphical user interface, that means the dashboard. And then you push all the configuration where into the controller. And the controller, for example, will push all the configuration or the policies from here to every device. I hope so till you're okay. So that means earlier I need to configure every device box by box manually through the CLI. Now I am sitting here and now I am configuring all my networks. I am designing all my networks. I am collecting all, for example, the logs sitting here. And I configure here and everything is how no more, for example, CLI through the GUI, graphical user interface. And I push the configuration to the controller and controller will push the configuration to the, for example, the devices. So this is the SDN. Now the SDN, I hope so till here everyone is okay. You are familiar with this technology. Now, I am just giving the brief here. Now the SDN provide a 3 different solution, one for the data center, In the data center, we call Cisco ACI. It's a hugely popular. One for the WAN, wide area network. This is called SD-WAN. In the CCI enterprise, you will not learn about this because this is a separate domain. This is a data center. So here is a WAN, and then another one is for the LAN, that means the enterprise, and that is called SD access, or we engineer normally call a DNA center or the DNAC. This is a DNA center. That means the purpose of all these solutions are the same. That means we want to manage, configure, monitor everything through the one central place. But these are the different solutions. Let's focus on these two technologies discussed in the CCIE enterprise with very depth. One of these technologies, these two, for example, the technologies discussed in the CCIE enterprise. Let's talk about the SD-WAN. Software defined WAN. Of course, we know that what is the meaning of WAN. What is the meaning of WAN? WAN means connecting the sites, that means the branches through and those branches are in the different geographical locations, maybe in the same cities, maybe in the different cities, maybe in the different countries or different continents. So that means the simple word is what? Connecting the sites, the branches, connecting the sites. Now the again question appear in my mind as an engineer, okay, why should I implement WAN in my network, SD-WAN? What is the reason behind that? Let's talk about this. Okay, why SD-WAN? We have a question answer session after this. Let's talk about till now we engineers, how we configure and which kind of the problem we face in the traditional WAN. Forget about the SD-WAN. Let's talk about the traditional WAN. Usually, if for example, let's say I have my headquarters and I have, for example, the branch 1, branch 2, branch 3, multiple branches. Let's say my headquarters are in Riyadh and my branch 1 is in the Jeddah, for example, Dammam, let's say, for example, Dubai, let's say, for example, Bombay. Yeah, I'm from Bombay. Okay, now how we connect, for example, we have a different kind of the transportation here. Okay, how we connect these sites? Either, for example, we use the MPLS, one of the solution to connect the sites. We can use, for example, internet service provider, the VPN, DMVPN, and we connect, for example, like this. And usually, for example, let's say this one is a primary, our MPLS is a primary, and the normal internet or the 4G, 5G is a secondary. And we prefer all the traffic should forward through the primary. If the primary is not available, then the traffic should forward through the secondary. Okay, this is usually we connect the sites. Now, before 15 years, you as engineers, you face a different issues, and now 15 years, last 10 years, we are facing the different issues. Okay, why? Because the network and the demand of the network is different now. Let's talk about this. Which kind of the issues we face? Let's say, for example, we have a data center. This is, for example, our data center. The data center. Let's imagine this is in the Riyadh. And here we have, for example, the servers, application servers, for example, database servers, web servers, and so on. All these are the servers. And they are connected, for example, here. Then what we bring here? We bring, for example, of course, the firewall. I just make the one firewall. Of course, here we bring, for example, the load balancer also. Let's bring the F5 here because we have thousands of servers. This is a firewall. Now then here we have a branches. Let's say for example here we have here for example headquarters. Then here for example my branch 1, branch 2 and so on. Here we have for example in the branches of course the users they are using for example computers, laptop, wireless devices and so on. Switches, routers and so on. This is a just imagine our branch offices. Now what here we need to connect for example our branches to the data center. So here we bring, let's say our primary link is a MPLS and our secondary link is for example let's say the ISP. All branches should go through the MPLS, through the primary link. If the MPLS is not available, then forward the traffic through the ISP. So we configure the site-to-site, DM VPN, and so on here. The MPLS is our primary, and this is our secondary. Now look at here, the point number 1. Our company's policy says any user, if want to communicate with the servers or anywhere, should authenticate with firewall, because we create all policies in the firewall. Okay, I mean all policies we configure onto the firewall. That means let's say this is me, I am the user in one of the branch. I want to access for example the database servers or the FTP servers or any kind of the servers from the data centers. So I will use the primary path, that is the MPLS. Then I will go to the firewall. Firewall will authenticate and then pass through this and then return back like this. This is so all the branches, for example, the all users from the branches they go through the same policy. Now what? Now for last 10 years, our demand is a different now. Now we are going towards the cloud because we are getting some services, some servers in the cloud. So let's say, for example, here we have a cloud. In the cloud, we have a few services like, for example, let's say the Office 365, Dropbox, Salesforce, and for example, let's say the WebEx and so on. Few servers are in the cloud. Of course, the cloud, for example, let's say we are connecting the cloud. Now what? Let's say, for example, one of the user want to access the one of the application and that application belong to the, for example, UDP, that means the RTP. Let's discuss about the, for example, VoIP, voice over IP. So if, for example, let's say this user want to go to the cloud, our company's policy says what? If anyone want to go to the internet or cloud or the data center, go through the first MPLS, then we will authenticate here. Just 1 minute. Okay. Authenticate and then return back to the cloud. And then return back from the cloud. Again, we will go to the firewall and then, for example, the MPLS and then return back to my branch. For example, either here or here. This is called, we engineers, we know that this is called suboptimal path. This is called what? Suboptimal routing or suboptimal path. What is the meaning of this, Shabab? So suboptimal path means I can directly go to the cloud because I have a connectivity, internet connectivity. I have that means what? I have a short path, but whatever the reason is, here in our situation, the reason is a policy, the company's policies. Okay, so whatever the reason is, I am not using the short path. I am using what? I am using the long path. That means I'm going through the MPLS, then return, and then like this. This is called suboptimal path. So I am not using the short path. Okay, there is a question appear in mind. Okay, why should I go to the firewall? Okay, the another solution is as an engineer. So I should bring, for example, in every branch the firewall. But what about the cost? My management not agree, for example, for this because this is a huge cost. Or maybe, for example, we don't have budget. So as an engineer, what is our other solution? The other solution is we need to implement firewall to the each and every branch, but we don't have the budget. We don't have the cost. We are facing the issue of the cost. So we have here a 1-2 firewall here. So that means we are going to the here. So this is the issue. Another issue is what? Let's say, for example, one of the branch manager want to join, for example, the WebEx meeting. Okay. He is joining, for example, the meeting. That means the VoIP application. And we know that the VoIP application, Shabab, is a very sensitive for the delay and the jitter. The very sensitive for the delay and the jitter. So if we are using the long path, that means, for example, is of course is affect our VoIP application. Call quality. It will affect. If, for example, this meeting is unsuccessful because of the call quality, the manager, for example, the branch manager is not able to listen properly, not able to deliver, for example, not able to present the project very well. So then what? This is, for example, our loss. Why loss? Because our company's policy says we should go through the MPLS and then the authenticate with the firewall, and then, for example, we can return back through the same way. The long path we are using. Then let's say one of the user, for example, one of the users want to access, for example, I'm talking about this is all are the traditional network. One of the user from the branch, for example, want to go to the Google, Facebook, YouTube.com, or for example, the internet. Okay, I have a connectivity with the internet, but I'm not accessing. This is not my policy. Why not? For example, let's say I am the user and I want to access, for example, my Gmail. Okay, in the Gmail or the Yahoo or the Hotmail, for example, there is an attached file in my email. Okay, who will give me a guaranteed that there is everything is okay with this attached file? That means what? I need to check DPI, deep packet inspection. I want to monitor this, what is inside this file. That means what is inside this payload, the content. So we need to do what? The deep packet inspection. That's why we bring what? The next generation firewall here. We deploy the next generation firewall. So if I am accessing the internet directly, so once I return, so maybe, for example, in the attached file, there is a virus, there is a malware. So we need to check. So that's why this is our company's policy, but we are using the long path. Point number 3, let's say, for example, there is a one more branch here. There is a one more branch number 3. You engineer, you know that if we deploy the new branch, there is a lot of configuration we need. It's a headache. In the my previous batch, before two batch of my previous batch of my Ccie, one of the engineer, he faced the issue. So they deploy the new batch in the Highel area. So it's a huge issue. So we engineers, we know that if we deploy the new batch, we need a lot of configuration. We need to check the, for example, traffic. Okay, the traffic is moving properly or not. Let's say, for example, there is another issue. Okay, this is our let's say, for example, this is our primary link, the MPLS. Let's say, for example, 200 MB, whatever. And this is our backup link, the 50 MB or 100 MB. We are going through the MPLS. The MPLS service provider provides us agreement, SLA. The MPLS provides us SLA. For example, let's talk about, for example, delay and jitter. Let's say, for example, they say the delay is 30 milliseconds. Okay, the 30 millisecond here. Now what? I'm sending all the traffic through the MPLS. And now, for example, in one fine day, that is, for example, let's say that is the bad day in our office. So this is the MPLS delay is reaching to the 45 millisecond, 55 millisecond, 60 millisecond. That means what? This is, for example, not good for, let's say, our VoIP application or the other applications, the 45 millisecond or 60 millisecond or the 70 millisecond. Then who will inform me? Okay, the MPLS, for example, MPLS is not working properly, so you should switch the traffic. This is called a traffic engineering. We should switch the traffic not through the MPLS. We need to switch the traffic through the ISP. During that time, the ISP is working fully fine, absolutely fine. So that means what? Okay, we can implement, for example, monitoring tool. Okay, I have 100 of branches. Let's say one of you, the engineer, you are working in the bank. We know that if you work in the any XYZ bank, the banks has so many branches on each and every city, even the small towns. So how can you monitor, for example? How can we monitor? So we are facing, for example, the lot of issues. If I, for example, bring the new branch, I need a lot of configuration. And if I make, for example, the VPN, the DM VPN, so that means what? I need to implement the IPsec. And we know that, for example, to deploy the DM VPN, the IPsec in the branch side, let's say we need a minimum 15 to 20 commands. Then we need to check the how the traffic are moving. So that means, and we are doing, for example, the manual. Let's say, for example, we are in the Riyadh or Jeddah. Let me give the one example. Let's say, for example, in the Riyadh, okay, the Abad net, I am from the Abad net training center. Abad net is located in the Roda. And let's say, for example, I want to go to the Ulayya. To reach from the Roda, from Abad net to reach Ulayya center, for example, I have a three different, for example, tariq, three different path, the way. Okay, usually I use, for example, let's say the path number one because it's a less, for example, the traffic. Usually it's take me the 20 to 25 minutes to reach Ulayya. But one day, for example, there is a too much traffic, the Zahma, congestion on the road, on the street. And is I use the tariq number one and is, for example, take me around 1.5 hours. It's happened with us in every city, in every country. 1 or 2 days in the month, or for example, sometimes it's a too much traffic due to the, for example, whatever the reason, due to the, for example, let's say the uh, accident or anything, for example. That means what? Okay, I reach. Let's say I want to reach at the meeting, but the meeting is over because I am not able to reach there on the time. It's take me, for example, around 1.5 hours. Okay, so I need what? I need somebody should inform me in advance. Ki Abdulazeem, don't use the path number one. It's too much zahma, too much traffic in there, too much congestion. So use the tariq number two, the path number two. And nowadays, of course, you are smiling. So nowadays we have what? A Google map. The Google map provides us that information. So Google Maps save us. Okay, this is, for example, I am talking about I am reaching from one place to another place. What about my network? What about my WAN network? That means somebody should inform me, or somebody should, for example, inform me, monitor my traffic. Okay, this time there is a issue with the, for example, MPLS connectivity is too much delay. Okay, so that's why automatically we want to, for example, switch or route the traffic from the next available, for example, transport like ISP or 4G or the 5G or whatever. So in the traditional WAN, we engineers for a lot of years, we face a lot of issues, the configuration issues, For example, monitoring issues, the policies issues, and so on. So then how can, for example, who will solve the issues? How can we solve the issues? So then the SD-WAN come into the picture. The SD-WAN come into the picture, and the SD-WAN says, okay, to all of the network engineers, service provider engineers, okay, I will solve your issues. I will give you the better solution. So now we know that how the SD-WAN come into the picture to solve all the issues what I discussed earlier. So let's talk about how the SD-WAN solve the issues one by one, and then I will take the question and answers. The first thing is we discuss SDN decouple, separate control plane and data plane. Let's talk about this. So here, SD-WAN, we have a control plane, or normally we call a controller. In the SD-WAN, we have a multiple controller. First is we manage. V bond. This is coming from the James Bond, V bond. And V smart. Let me clear all of you, the engineers. V means not virtual. In the SD-WAN, Cisco SD-WAN, the V means not virtual. V means Viptela. V means Viptela. Actually, for example, this project developed by the company Viptela, the 3 Pakistani engineers and the 2 Indian engineers, especially the 3 Pakistani engineers. So earlier they work in the Cisco. So they developed this, and the Cisco take over this technology from the Viptela. It's called a Cisco SD-WAN or the Viptela. So V means Viptela devices, V smart. And then there is a data plane device. This is a control plane. And then there is a data plane device or devices. In the data plane, we have a multiple devices. Usually popular are V edge. This device belong to the again Viptela, and C edge. This device belong to the Cisco. C means Cisco. Mostly the Cisco use the CSR 1000 series routers and different models. Okay, so this is a control plane and the data plane. Now look at here. I am managing all my branches, branch routers, branch devices through this. This is my management plane. That means if I want to configure anything, if I want to, for example, configure or implement the policies, or if I want to collect the information, that means the monitoring or managing everything through the single dashboard. This is a vManage. This vBond is orchestration plane. The vBond is orchestration plane. That means the authentication. Who are you? First, you need to authenticate, and then I will allow you to work in my, for example, fabric. So this is orchestration. Orchestration plane, or we can say the security, authentication. vSmart is our controller to push the policies, And vEdge means our branch routers. Cedge means our branch routers. Let me show you the one demo here. 1 minute.